name is Alexander Makarov. I'm the team leader of Team Fleet Manager. My team members are Mark Duncan, Kyle Smith, Douglas Payne, and Gilberto Estrella. We're Team Fleet Manager. We're an Internet of Things project championed by AT&T.
Okay, thank you very much. So please summarize in general what your project is.
In general, what we want to do is take the car into the 21st century. We want to be able to track all the internal data of the car using the OBD sensors as well as using the wireless mesh network that we developed. Typically, all the solutions out there in the market currently utilize the OBD sensors. We want to take a step behind above that.
Excellent. So tell us about each team member's contributions to the project.
Well, as I mentioned earlier, I was the team leader and the hardware and software designer, so I provided the requirements, the specs, and the testing plan of how this was implemented. Mark Duncan was the other hardware spec. He was our hardware specialist on the project. Gilberto Estrella did the administrative data. He did the hardware circuit design, specifically power circuits, and he did a lot of the financial funding help us out a lot with that, as well as the business case. And Kyle Smith was our web UI designer. And Doug Payne did the Android app that we have on this project.
Good team. Please show us your working prototype and explain about how it works in more detail.
Sure. So if you can come a little closer. We have multiple units here. So we'll begin with the first main unit. That's the brain. So this unit has two Bluetooth connections on it. One Bluetooth connection connects to these OBD2 simulator that was provided kindly by the school for us. It simulates the OBD information inside a car. So it's essentially a car for all practical purposes. And then we have this OBD sensor can connect to a 3G Shield module like this, or it can connect to your personal Android phone like that. And then we have an RF 2.4 gigahertz sensor as well for our mesh network. Now, there's two parts of this project. The first is the OBD connection, where we're gathering data about the car using the OBD simulator. And the second portion is our wireless mesh network with node relay. Essentially, what we want to do is gather any sensory input that might be relevant to a specific car. These sensors are highly configurable. You can reconfigure them at will, have them track any data that you need. They can pretty much do anything that you want. And they're wireless, so you can simply drop the sensor in the network and take it out at will. Currently, they're running off batteries for the sensor for the demo, but they can be literally any sensor as long as it follows our communication standard. Now, all this data is gathered by this main unit, this sensory data and this OBD data. Once the sensory data is gathered, it's either sent to the 3G Shield or it's sent to our Android device for the app that was written by Doug. So, as you can see, that's a debug menu right there. And then we have the actual car with simulated temperature. It can be a car, it can be a fleet transport, and such, and so on and so forth. Once this data is gathered, it's actually pushed to our web UI. We can then track car performance and history over a span of time. You can actually select the dates you want to see how the car has been performing. This is for the fleet management portion of it. Yeah, that's about it.
Yeah, great, excellent.
I just thought data was populating.
Is there something similar out in the market?
Yeah, so there's a lot of different solutions for this in theory. There's OmniTrax that does a fleet management simulation. There's OnStar that we all know from GM. There's two differences, however. First of all, there's two differences, however. Number one is that all their systems are typically proprietary. This is an open platform. And number two, which is important, is that most of them simply rely on the OBD data as the end-all be-all solution. We don't do that. We actually have our own wireless mesh network that goes above and beyond the OBD2 data, and that way we can get any data we want into the system that might be relevant. And I think I answered your next question.
Yeah. Is there something else about the prototype that's better or unique from what's out there?
Sure. Sure. One of the things that might be also better and unique is that first of all, this system is highly modular and highly configurable, which I haven't seen in a lot of other prototypes, and it's fairly cheap. Before economies of scale, each one of these nodes is only about $10. When we have economies of scale kick in, those are really cheap chips, and you can upgrade them fairly simply. Also, it's completely hardware independent, so if you were to go out and replace all of these chips with something else, that you could do it at a heartbeat, so long as you follow our communication standard.
Okay, great, thank you. How has this prototype developed from the UTDesign 1 phase?
The entire change from UTDesign 1 came out of UTDesign 1 with a working prototype already, but the main issue was reliability. So number one key feature for this entire system was reliability. We're using two-way transmitters. We're using node relay. So if a node is really far away from the base node, it can still transmit through other nodes and hit the sensors, so we have no data loss. We're also using Android instead of just 3G shield, so we can actually see the data flow. And we've sped up our sensors because the 2.4 GHz radios are faster than our 434 megahertz. We have a lot more sensors built up and mocked up. Our website UI has improved greatly, and our backend has improved greatly because we can take more data at a faster rate. We can process it a lot faster too. And we also have the Android app, which we did not have, because that allows you to see everything in real time, which is quite nice.
Great, thank you. So if you think about the future and how technology changes so quickly, like from Senior Design 1 to Senior Design 2, what future changes or possibilities could arise again for this product?
So, for example, we've already talked about how to upgrade and improve this project. One of the things is PCB design, but other than that, we can use lower power chips. We can improve the radios, have lower power radios to increase the lifespan of the battery. Team 21 is one of the Senior Design 1 teams currently working with UTDesign, and they developed a power solution that can actually power our sensors in a much more efficient way, work a lot better. So we can implement their solution into our project and improve our battery life and efficiency in that as well. And this system is hardware independent, so when better hardware becomes available, we can integrate it and utilize it in our project and move its